Hello students, welcome to Educate. In the last class, we have discussed about the chemical properties of amines. Now, one question was left. About that I have told you of this question. About that we will discuss, and about the diazonium salt we will discuss in this class. These questions were so much easy. This question is also easy, but problem here is that in case of NEET examination, questions ask how much isomers will form by that compound. So students, do the mistakes in those questions. It seems to be easy. That's why almost every students who have devoted the time in the study, they attempt this question and do the mistake. Not responding is better than that of wrong response. You already know about that. So let's see here to solve this question. It is formula is C3H9N. So first of all, let's this one primary amine. Then after take one methyl. So it is simply propanamine. Then after take one methyl from here and attach to this one. So when you will take one methyl from here, main chain will be of 2 carbon, in which a methyl group will be bonded to the second carbon here, first carbon, and here. So how to write the name? Here 1, 2. So at first position there is methyl here. No. If anyone tell that methyl here substituent, no, chain not terminates here. Okay, listen then what is here? Chain is 1, 2 and 3, and it is propane 2 amine. It is propanamine. It is propane 2 amine. Of the primary amine, these two possible. Now let's see, secondary amine may be there. So Hos, nitrogen here. So one CH3, CH2, and here CH3. Its name will be N-methyl in the same way, tertiary amine can also be formed. So what will be there? So how much isomers has been formed? 1, 2, 3, 4. So in the NEET examination, question may ask that amines having molecular formula this one, how much isomers will form? Okay, and option will be there. So you will have to predict. So I suggest you draw the structure and write their IPAC name also. If IPAC name will be same, then compound is same. So that will be not the isomer. Now let's see. So that was the questions was discussed. Now let's see diazonium salt. About the diazonium salt, you are already familiar that in diazonium salt, the N2 group bonded to the benzene. How there is N2 group? That is how it stabilizes. So nitrogen take the electron from this side here, triple bond here between the two nitrogen there is triple bonding. So the nitrogen attract the pi electron towards itself. So here will be negative charge, and this nitrogen will have positive charge. To neutralize this positive charge, the shared pair of electron here comes for the bond formation. So here double bond, here positive charge, and that's proceed. You already know how's that. So here positive charge. So to neutralize this positive charge, here the shared pair of electron come here for the double bond formation. So here positive charge. You are already aware. Then after this method of preparation of diazonium salt, a number of times you have prepared the diazonium salt by reacting with HNO2. That means here the aliphatic or aromatic, whatever be that. So react this aniline with the HNO2 or the mixture of NaNO2 and conc HCl. The mixture of NaNO2 and conc HCl here. So this will react and form HNO2, and as a result benzene diazonium chloride form. You are already aware about that. That's why I am not discussing. This one method of preparation of aromatic diazonium salt, that is called diazotization. The method of preparation of aromatic diazonium salt is called diazotization. Okay. Now let's see. Physical properties, it is colorless and crystalline solid. That is, diazonium salt is colorless and crystalline solid. Okay. So that's here that you may write that benzene diazonium chloride is a colorless crystalline solid. So obviously soluble in water. Why soluble in water, you may think. And diazonium salt is highly unstable compound. That's also you know. Let's see here about that chemical reactions. So there benzene, that diazonium salt shows two types of chemical reaction. One is reactions involving displacement of nitrogen. That means there will be some reactions in which the nitrogen will release from the diazonium salt, and there will be some reaction in which the nitrogen will retain by the benzene or the aliphatic carbon, only benzene actually. Benzene, because aliphatic diazonium salt is highly unstable. Okay, aliphatic diazonium salt is more unstable than that of aromatic diazonium salt. So here reactions involving displacement of nitrogen, about that let's see. Because you are already familiar about the about these reactions, so no need to write on the whiteboard. You can understand this one very easily. What happened? This diazonium salt, when you react with Cu2Cl2 and HCl, that is haloalkane will benzene here form, bromobenzene, and benzene nitrile will form. This one. So what is here? Keep in the mind that about the Sandmeyer reaction and the Gattermann reaction. Yes, Gattermann reaction. Sandmeyer's reaction is when you react Cu2Cl2 with the diazonium salt along with conc HCl. When you will react the benzene diazonium chloride with Cu2 Cl2 or Cu2Br2 along with HCl or HBr, then the reaction will be called Sandmeyer's reaction. And when you will take only copper powder on the place of Cu2Cl2 or Cu2Br2, when you will take the copper powder, then the reaction will be called Gattermann reaction. We prefer the Sandmeyer reaction because yield in the Sandmeyer's reaction is more than Gattermann reaction. Okay, maybe you get confused, so I am writing here. Suppose Sandmeyer's reaction, what here? This one you have taken, that's react with Cu2Cl2 plus HCl. So what happened? Chlorine, this chlorine combined with again this copper, this chlorine go, nitrogen releases from there. Here chlorine plus nitrogen, again Cu2Cl2 form, so it will act as catalyst. Or another reaction here. So bromine will attach in this case to the benzene. Nitrogen will be born. It is Sandmeyer's reaction. Here to prepare KCN, so you take CuCN or KCN. That reaction. So that is also Sandwich reaction. So CN group, cyanide group will replace this nitrogen. So CN means attachability here. That is Sandwich reaction. So in Sandwich reaction, we react the benzene diazonium halide with or what any that means HSO4 minus whatever be that. So benzene diazonium halide or benzene diazonium hydrogen sulfide like that with Cu2Cl2 and conc HCl. And during Ketterman reaction, we will have to take this diazonium salt with copper and HCl. So product will be same. Product will be same, but name reaction has been different. Same. Okay guys, that is here about the Sandwich reaction and Ketterman reaction. Now direct iodination or fluorination in benzene is difficult, as you have studied in the first chapter. Direct iodination or fluorination is difficult. So from benzene diazonium halide or benzene diazonium salt, any other, that means there HSO4 minus also any other compound will be also. So when the benzene diazonium salt will react with Ki. To prepare for iodobenzene, we will have to take Ki on the place of Cu and Hi. Cu or Cu2I2 we cannot take and Hi. So to prepare the iodobenzene, we will have to react the benzene with Ki. We will have to react the diazonium salt with Ki. Okay, and to prepare fluorobenzene, the diazonium salt will have to react with hydroboric acid. Oh, sorry, this one, fluoroboric acid. Okay, so write that. Okay guys, this compound form, and then after fluorobenzene will form. Okay, replacement by hydrogen there. So what are here, just watch out next reaction. Watch out this reaction. H3PO2, it is hypophosphorus acid. Hypophosphorus acid. So what happened? It will get oxidized. When it will get oxidized, so that will become phosphorus acid, H3PO3. So it will get oxidized to H3PO3, and here chlorine will combine with hydrogen, form HCl. When hydrogen released from here, hypophosphorus acid, so HCl will be formed and nitrogen will get released from there. Okay, so that is here this compound. This one here, same alcohol will get oxidized into aldehyde. So aldehyde, so ethanol here, nitrogen will release and hydrogen release from here, that will combine with chlorine, form HCl. Same water here, same about this one, chlorine will combine with one hydrogen because H plus and OH minus ion. So chlorine will combine with hydrogen, form HCl, nitrogen will release, OH minus ion will get bonded. NO2 group. So how to prepare the nitrobenzene from there. So to prepare the nitrobenzene, first of all, we will react the diazonium salt with fluoroboric acid. So this compound will form. Then after treat with NaNO2. So NaNO2, then after you will treat. So what happened? So BF4 minus AIs. It will release from there and sodium will combine to there. So sodium will combine here, sodium positive, NO2 minus negative. So Na plus will combine with BF4 minus, so that become NaBF4, and nitrogen will get released and NO2 will get bound here. So that is here. In this way, nitrobenzene will form. Okay, so that was the reactions of diazonium salt in which the nitrogen was replaced. Now let's see another reaction. Here retention of this one. Reactions involving, now let's see reactions involving retention of diazo group coupling reactions. That is, this reaction is also called coupling reaction. Be careful. Coupling reaction, that means here the two group we are adding there. We are make the couple. So that is coupling group. Coupling reactions here. So let's see about this reaction. This is the diazonium salt. Here phenol. So hydrogen of the para position of the phenol will combine with chlorine, form HCl. So balance of this carbon atom become destabilized, and that of this nitrogen. So this nitrogen will get bound to this carbon. So this product will form, and Cl minus release. So that will combine with this hydrogen. So form HCl. Here not written. So HCl. Same here. It will be here oxygen here. This group here, that is called azo group, and it will be responsible for color. If there be azo group in the compound, then in most of the cases, then almost everywhere, the compound will be colored. Of which color it will be, that will depend on the groups bonded to left hand side and right hand side. That will be, what will be the color, that will be decided by the group towards left hand side or towards right hand side. So this one, what is here, when OH is there, so that will be of orange color, and that will act as orange dye. In the same way, when benzene diazonium chloride will react with aniline, then hydrogen of the para position, that will react with chlorine, form HCl, and nitrogen, this nitrogen will react combined with this carbon. So here same, this azo group and NH2. This side there is NH2. Here was OH, so that was orange dye, and this side NH2, so that will be yellow dye. It will act as yellow dye. Okay. So if you confuse in the examination when NH2 was then or when OH was then, what the color? So OH, oxygen there is, so orange color, OO, and here NH2, so that will be yellow dye. Now let's see another one. So that's the done. This chapter is done here actually. Importance of diazonium salts. So you have seen that this diazonium salt is used to prepare a number of compounds. There are some compounds also. Which we cannot prepare by the aromatic haloalkane. From that, by the nucleophilic substitution reaction, we cannot prepare. So during that course, we use the diazonium salt. Okay. As for example here, it is good intermediate for the introduction of this one. So this group you can attach there for the diazonium salt. Very easy it is. Now let's see about this question. You have to convert 4-nitrotoluene to 2-bromo-benzoic acid. Okay. Again, I am telling by writing this one. Otherwise, you feel difficulties. 4-nitrotoluene it is. So firstly, draw the structure of 4-nitrotoluene. And you will have to prepare on the 4-nitrotoluene to 2-bromo-benzoic acid. 2-bromo-benzoic acid. So here, benzoic acid and 2-bromo. So at second position, bromine. How to prepare? So in this compound, you will have to attach bromine to this position. During the conversion, you will have to attach bromine to this ortho position, converted to this CH3 into COOH, which you can do very easy, and NO2 you will have to take out from there. So how's the main challenge here is to how to take out NO2 group from the benzene. So guys, right now you have seen the reaction that NO2, if NO2 will be converted into diazonium salt, and then after that will be treated with H3PO2 or the alcohol, then the diazo group, that means from the diazonium salt, the diazo group will be replaced by hydrogen. So then NO2 group could be released. And to convert CH3 into COH, very easy it is. You react with a strong oxidizing agent like alkaline KMNO4. So alkaline KMNO4, so CH3 will convert it to COOH. Okay. So now should I go on the books directly? No, don't go. So firstly, bromine you will have to attach. So firstly attach the bromine. So how you will attach the bromine? So this reaction here is, so react bromine in presence of CS2, like that, bromine in presence of CS2. So what happened? One bromine with a nitrogen here, it is meta-directing group, and CS3 is ortho-para-directing group. With respect to methyl group, already there is NO2 group at the para position. So let's see about this carbon here. This is meta. So CS3 will not give the position here. So this position is ortho with respect to CH3 and meta with respect to NO2. So bromine will get bonded to this one. Same here to this carbon. So bromine attached to this carbon or to this carbon, whatever be that. The bromine attached to this carbon or to this carbon, the same compound will be that. So what happened? From here, one hydrogen will combine with this bromine form HBr and another bromine will get bonded. So structure will be bromine will get bonded to ortho position. This done. Then after, if you will have to mention here challenge is to remove this NO2. So how you will remove this NO2? So a number of reactions there is: hydrogen and palladium, or strontium and conch HCl, whatever be that, whatever you want. Either for this one you do or this one you do. So what happened? Hydrogen will replace here. So aniline firstly, to replace them to convert the NO2 into diazonium group. The NO2 will have to convert into NH2, that is amino group. How? With it will convert into NH2. So you will have to react with the mixture of strontium and concave Cl or the hydrogen and palladium. If you will take strontium and concave Cl, then reaction will be fast and easy also. But you can also take hydrogen and palladium. So what happened here? NO2 group will convert into NH2. And aniline NH2 group can be easily converted into the diazo group. So how? You have to react with HNO2, and that HNO2 will form by reacting sodium nitrite and concave Cl. So HNO2 will form by the reaction of sodium nitrite with concave Cl. So this one react with HNO2, and that is formed by sodium nitrate and conc HCl. So this NH2 converted to N2 plus Cl minus. So this compound become and then after react with H3PO2. So H3PO2 will oxidize into H3PO4. So hydrogen released from here, that will one hydrogen will combine with this chlorine form HCl, nitrogen will get released from there. So that's here, hydrogen go. So this product will form. Here CH3 and here bromine. Because at this position hydrogen will get attached. So we don't show the hydrogen. Then after this, then after take a strong oxidizing agent like alkaline KMnO4. So we take alkaline KMnO4. So alkaline KMnO4, this CH3 converted to COH. This compound easy. Watch out, I am giving you 1 minute time. Watch this one, if here, is it clear or not? Watch out. Hope it's clear. Now proceed. This is also of the conversion. You have to convert 3-methyl aniline into 3-nitrotoluene. So let's see the draw the structure. Read the question. 3-methyl aniline, that into 3-nitrotoluene you have to form. So let's see. Because the space will be limited, that's why I will have to take it short. I will have to make this one short. 3-methyl aniline. Aniline is NH2 attached to the benzene. And 3-methyl means here CH3. 3-methyl aniline into 3-nitrotoluene. So here you will have to make, here this NH2 will have to convert it to NO2. Now how this NH2 converted to NO2? If someone will take direct reduction, hydrogen and palladium, guys, Reactive, and NO2 is not so much reactive that it will react with hydrogen very easily. Yeah, aldehyde was reacting with hydrogen very easily, H2 directly, but NO2 will not react. Okay, its reactivity is not so much with hydrogen, H2. So let's see here how to do this compound here, 3-methyl aniline. Okay, this will same here. So firstly you will have to convert to diazonium salt. What you will do? Firstly you react with your aniline. You can convert the aniline very easily into diazonium salt. As in the diazonium salt by reacting with HNO2, which will form by reacting the NaNO2 with conc-HCl. So here this compound will react with NaNO2 and conc-HCl. So it will be N2 plus Cl minus and here methyl. And this diazo group can be very easily replaced by NaNO2, could be very easily replaced by NO2. Because when this compound will be treated with NaNO2, that is sodium nitrite. So chlorine will combine with the sodium, form NaCl, nitrogen will release and NO2 will get bond here. Okay, that is, so that was easy. Now let's see another one, third one. Read the questions. Have I to zoom? Okay, let's just zoom. It is aniline into 135 tribromobenzene. This reaction could be solved in a single step. Aniline can be converted into 135 tribromobenzene very easily. Bromination at all the three positions was very easy, you have seen. But to prepare the mono-substituted bromo derivative of aniline is difficult. But that was prepared. How's? Recall that U was decreasing the electron cloud density at the nitrogen atom. Okay, and how's that? The aniline was reacting with acid anhydride, and then after the bromination was done. Okay, recall that the previous reactions. Okay, of this chapter only, not of the other chapter. So aniline here, so it's very easy. Aniline that will have to react with bromine here. Bromine water is Br2. So at all the three positions, the bromine will get bonded. One, two, three, four. One, two, three, four, five, six. There is written here something difficult here. It mistake here. That is 2, 4, 6. That is tribromobenzene. Oh, guys, no. Let's see. This one is quite different. No. By this method, we can prepare 2,4,6 tribromoadenine, but not 1,3,5 tribromobenzene. So let's see how to solve. So this one is method. That was the reactions which I did. That was for the preparation of 2,4,6 tribromoaniline. But here, no aniline here. Tribromobenzene here. 1,3,5 tribromobenzene. So let's see here. Just do this reaction. Aniline here. This one you will have to prepare. So how to do? First step, prepare into diazonium salt and diazonium salt. So react with NaNO2 and conc HCl. N2 plus Cl minus, and then after with Cu2Cl2 and HCl. Oh, sorry, not here. Then after with NaNO2. NO2 will attach. Then after you have to do the bromination. So bromine here will attach this one and this one. So why at 3 and 5? Because NO2 is meta directing group. So it will give position to the bromine at meta position. So here and here. This one. Again, then after you will have to replace this NO2 by the bromine. So what to do? Convert this one into this NO2 into diazonium salt. Convert it to diazonium salt and then after replace by bromine. So what to do? Here strontium and conc HCl take. So here that will convert it to aniline. After that react with HNO2, which was found by reacting with NaNO2 and conc HCl. So diazonium salt form here. Better you take HBr. On the place of HCl, take HBr. So HBr. Now this compound react with Cu2, Br2 with HBr. So this bromine will go from there, nitrogen metal is there. Guys, might be you will feel that how much lengthy these reactions are. But when you practice this one, because about these reactions you are already familiar, and if you will solve, that means the reactions about which we have discussed, if you will solve, then that will remain in your mind. And when the conversion questions you will do, then you will do by automatically. So the questions here, so this one here, since this conversion was in the in-text question, that's why I have solved the questions of the conversion of the various chapter, either of halogen, halodine, alcohol, aldehyde, or of the amines. About that we will discuss after completing this organic compound. Okay, so first of all do this one done. Okay, so first of all here, because you are already familiar here, when you will practice, then you will convert the compound very easily by yourself also, depending on how much you have practiced. If you will practice more, then automatically you will convert. And yes, the way of conversion will be different in case of different students. They are not necessary in which way I have converted. In that manner you convert. In that manner only you convert. That's not necessary. You do apply that reactions about which you are too much fluent. Okay, so now let's see. So that was summary. You should study summary because all of there is. So summary you study there also. Now let's see the exercise question. This one, this nomenclature very easy. This one is easy, easy. Okay, okay, but about the third, I am solving here. That is, guys, here it is CH and that is CH3 whole twice. So to this nitrogen there is CH, and with this one to this CH there is 2 CH3. So now how to write the IPAC name? Guys, again be careful. I have drawn like this. So if someone students will take only 2 carbon chain, that will be wrong, or these 2 carbon chain, that will be wrong, guys, because here chain have not terminated. Chain has not terminated here. This side also a carbon chain which is bonded to this carbon. So that's why chain has not terminated. Length of the chain is of 3 carbon. Now methyl group is bonded to the nitrogen, so that will be N-methyl. So what will the name? N-methyl propane 2-amine. This one is also very easy. Structure I am drawing here. This carbon here. Here NH2 is bonded. Now 3-methyl group is bonded to this carbon. So here. What happened here? Chain, this carbon is bonded to the functional group. So this carbon must be included in the main chain. So chain will be this one, either this one or that one, whatever you want, you would like to take, will not affect. So this one, and here methyl is bonded to the carbon atom, not to the nitrogen. Here in this case, the methyl was bonded to the carbon, to the nitrogen. So that's why we have written N-methyl. But in this case, the methyl group is bonded to the carbon. So simply we will write the position of the carbon and methyl. So it will be 2-methyl. And main name will be propane 2-amine, because NH2 is at second position. So that's why 2-methyl propane 2-amine. Okay, this one also. Now we are discussing about the fifth. It is benzene, 6,6H5 is benzene, and here NH and here CH3. So very simple here. It is aniline and methyl group is bonded to the nitrogen. So that's why name will be N-methyl aniline. Of this compound. So structure here, 2-ethyl group is bonded to the nitrogen. So here is nitrogen and attached 2-methyl group, 2-ethyl group firstly. And this nitrogen is also bonded to the methyl. That means in this compound, the 2-ethyl group is bonded to the nitrogen and 1-methyl group is bonded to the nitrogen. So what to do? Here chain between this one, this nitrogen is separating here, this part and this part. So chain can be anyone here. Chain will not come here because between these two there nitrogen comes. So chain is of not 4 carbon because between that a break is of nitrogen. So main name will be ethanamine, and this ethyl and this methyl, that will act as substituent. And alphabetical order, in the alphabetical order the ethyl comes first, so that's why we will write N-ethyl, N-methyl ethanamine. So its IPAC name will be this one here. Meta position is it's not the IPAC name. Ortho meta para, that's not the IPAC name, that's the common name. So structure here. So what's the problem here? This NH2 is in here. So 1, 2, 3. 3 bromo, aniline. Okay, guys. Now let's see this one. Gives the chemical test to distinguish between the following pairs of compounds: methenamine and dimethylamine. So what is here? Methenamine is 1 degree amine and dimethylamine is 2 degree amine. So you can use the isocyanate test, so that, because here one is that, so methylamine will form the isocyanate test and that will be foul smelling, and dimethylamine will not react with the mixture of CHCl3 and KOH. One is that. Then after this, you can react with Hinsford's reagent also. So when you react with the Hinsford's reagent, the product formed by this one, that will be soluble in water, it will be not soluble in water. Secondary and tertiary amine, same. The secondary amine will react with Hinsford's reagent, but tertiary amine will not react. Okay? About the reactions, you are already familiar. Next is ethylamine and aniline. Okay, you do that yourself. Aniline and benzylamine. Benzylamine, primary amine it is. So you do that. Aniline and anisotonic aniline. Okay, so this was easy. Now let's see. pKa of aniline is more than, about this one we have already discussed. Why ethylamine is soluble in water? Because there is hydrogen atom. Hydrogen atom there is, and in aniline the electron cloud density is less. So here that there will be, that could not form hydrogen bonding. Okay, about that we have already discussed. Methylamine in water reacts with ferric chloride to precipitate hydrated chloride. Why? Why here? Because in this case nitration was doing, so NH2 group was gaining the H plus ion, of which the NH3 plus is about this one. The NH2 group will gain H plus ion from the H2SO4 and hence will form NH3 plus in a linear ion, that is, of which the NH3 plus is meta-directing. So that's why meta-substitution product will also form. Why aniline does not react with Friedel-Crafts reaction? This one has been asked in a number of times. What happened here? Aniline. About that I have explained, but might be someone will tell that no, that was not actually the spoon feeding. I have informed you about this question, but that was not a spoon feeding. So this which I am solving here, that is just like the spoon feeding. So what is here? Question is, aniline does not undergo Friedel-Crafts reaction. So aniline here, that react with, in Friedel-Crafts anhydrous, we take anhydrous AlCl3. No, anhydrous AlCl3, that is acid, and aniline is base. So what happened? This compound with anhydrous AlCl3, that form a salt. This compound form the salt. So electrophile will not generate. So what happened? Aniline react with the anhydrous AlCl3, the catalyst used during Friedel-Crafts reaction, and form a salt. And therefore, there will be no generation of electrophile during the, okay. That is. Next one is here. Gabriel pethalamide synthesis preferred for synthesis of primary amines. Why? During Gabriel pethalamide synthesis, only primary amines will form. This one. A number of times. This one we have discussed. And in detail, I have taught you. Basic strength. Here in gaseous phase, different, and in aqueous phase, different. About that, I have already informed you. So here you do some work by yourself also. That was the spoon feeding, but through the spoon feeding, I have taught you. But revision you will have to do. Revise two, 3 times, 5 times, 10 times, as much you will do. Because how much you will revise, that much you will feel comfortable to solve the question. Revision, about that, what I can do? Yes, I can make the concepts easy, but keeping the information in your mind, that you will have to do. So but not so much, if you will revise a little bit, then also you will solve these questions. Okay. Now, conversion I shall do later on. Method of also chemical reactions, about that, carboylamine reaction, reactions we have discussed here. Carboylamine reaction used to distinguish primary amine. What is that? You are aware. Hofmann bromide reaction, Hofmann bromide degradation reaction. About that we have done the reactions. Go the reaction. Gabriel pethalamide synthesis. Very frequently we have discussed. Diazotization done. Coupling reaction, that is used to distinguish, that is here colored compound form. Keep in the mind. Acetylation you have done. Okay, this conversion here also. So about that, these questions we will discuss later on. NaCN, here this reaction very easy. 1-2 questions I am solving. So here this one, NaCN. So what happened? NaI, so carbon will come bound there. Then after, when you will do the hydrolysis, OH minus I, so carboxylic acid will form. Then after, with carboxylic acid, when NaOH and Br2 will react, then there will be formation of amine. Okay. Difficulty? Then okay, one questions I am doing spoon feeding. Okay, let's see. But that is too much easy. Listen, I am then doing here. This compound reacts with firstly NaCN. When you react with NaCN, so how much easy it is? Iodine will combine with sodium, form NaI, and carbon will get bond to this carbon. Why? Because NaCN will very easily dissociate into Na plus and Cn minus. Na plus will get attracted towards the negative species, that is I minus, and will form NaI. And then after of the Cn minus, since the carbon-carbon bond is stronger than that of nitrogen-carbon bond, that's why carbon will get bonded. So that forms then after is A is that is propane nitride. Now then after partial hydrolysis you have to do. So what you will have to do, this compound you will have to react with water, H plus and OH minus ion. So there is triple bonding between the carbon and nitrogen. So hydrogen will get bonded to the nitrogen and OH to this carbon. So compound become again water will react there. Same, even though again here nitrogen has low number of electron and more electronegative also. So that's why hydrogen will bond to this nitrogen and OH to this OH to this carbon. So compound become when there will be two OH group bonded to the same carbon, that compound will be unstable. The hydrogen of one OH will combine with another OH and form H2O. So here this hydrogen will combine with this OH and form H2O. So this oxygen will do double bond formation here. So product will be this one. Then after is reaction with NaOH and Br2. Watch out here. So 4 moles of NaOH was there. Recall the reaction about which we have discussed. So sodium will combine with this bromine form NaBr. Again this sodium will combine with this bromine form NaBr. And this NaO that will react with this one form Na2CO3. So there is formation of 2 moles of NaBr plus Na2CO3. The hydrogen released from here that will combine with this OH, and the hydrogen released from here that will combine with this OH. So there will be formation of 2 moles of H2O. Okay. Oh, I should write like this here. So there will be formation of 2 moles of H2O, 2 moles of NaBr, and 1 mole of Na2CO3. And this NH2 that will get bonded to this carbon. That will become CH3, CH2, NH2. So A is here, A is propane, A is here propane nitride, A is here propane nitride. Then after B is what? Finally product this one. This one I have told you just to how the reaction will take place. But actually there is formation of the carboxylic acid. No, there will be formation. No, sorry, this one amide. So it will be propanamide. So B is guys, it is CH3. Don't confuse here. So B is propanamide, and C is what here? Ethenamine. So C is ethenamine. Clear, guys? These questions also, as for example, I have solved first questions. Second questions here, you can do very easily by yourself. Diazonium salt react with CuCN, so CN will bond there. Then after with this one, water you will pass, so methonic benzoic acid will form. Then after ammonia will react, so amide will form. Okay, same here, KCN haloalkane, so CN nitrile will form. Then after will reduce, so imine will form, and then after react with NO2. So these reactions, any reaction is there is no any reactions about which we have not discussed. Okay, so this conversion you could solve very easily. If feel difficulty, then practice the reactions and watch out the video again. There be very less chances, bigger chances there is that any one of you will feel difficulty to solve these questions to this one. But if feel difficulty, then already the YouTube channel Educate happy to help you. Now let's see. So let's see here. There is aromatic compound A that is treated with aqueous ammonia and heating forms compound B, which are not with bromine and QH forms the compound C. From this one. Okay, so this question you firstly try. I shall discuss on that one also later on. Complete the reaction, very easy for you. This reaction, direct question it is, about which we have discussed. Third one is here. Why cannot aromatic primary amines aromatic? Why not can react with Gabriel pethalamide synthesis? About that, because in that one case the electron cloud density is less. About this reaction you already know. Why amines less acidic than alcohol? Because there is alcohol of comparable molecular weight. Because in amines there is lone pair of electron which can be easily released by the nitrogen, which can be donated by the nitrogen. That's why amines is less acidic and it is basic actually. Primary amines because that can do hydrogen bond formation, but tertiary amines cannot do hydrogen bond formation. That means the primary amines are bonded with each other through hydrogen bonding, while the tertiary amines are bonded with each other through van der Waals force of attraction. So as a result, due to the van der Waals force of attraction, as you know, the van der Waals force of attraction is weak. That's why that will possess less boiling point. Do that yourself. Okay. So this chapter got completed, and in the next class we will discuss the next chapter of organic. It's all for this class. Thank you, Team Educate.